Yeah, someone has raised their hand. Who is? If you have any query, you can ask. Okay. Okay. So before I talk about this quantitative methods, let me just give you a quick, view about this quantitative one, because this will help you. Uh, okay. So in quantitative methods, maybe there are different way of this quantitative methods, and there is also a qualitative methods. Okay. So here, if you see this quantitative methods or causal or this econometric, okay. So in this causal methods, obviously there will be some kind of a cause and effect. That is why it is called a causal, right? There are some factors which are causing something to happen, right? So there is one famous example that maybe if you eat maybe if there is some scorching, this heat, you are likely to buy this ice cream, right? But when you buy an ice cream, your car stops. So whether it is a correlation or causation, right? You don't know, right? So if you eat ice cream, let's say your car stops, right? So it will fall. You will say this is a causation, right? Or maybe it's a correlation, okay? But how are you gonna decide that it is a correlation and causations? Okay, I'm just putting these questions on you. But before I just explain you this correlation and causation, just see how this correlation works typically. Okay, so correlation is obviously it's a measure of relationship between the two variables. Okay, so how two variables are correlated? Okay, if let's say temperature is higher, maybe humidity may be higher or lower, right? Or if if you have, let's say, kind of, you can say the wind is blowing fast, maybe probability the rain, the probability of rain might be higher, right? So these are the some cases where you take up help of this correlation. Okay, so it is nothing but it's a kind of a linear relation between the two variables. If one is, let's say, if one element is increasing, if one of the feature is increasing, then there is a higher probability of other variables to increase or decrease in the same amount, or maybe some certain amounts. Okay, for example, if your sales is increasing, your revenue will also increase. So two variables which are going in the same directions with certain quantifiable value, they are increasing in the same direction. So it's a linear relationship. Okay, so one value moving in the same directions. For example, there is one of the case called there is something called economics stability, this Phillips curve, right? So in a Phillips curve, if your GDP is higher, unemployment is gonna decrease or something like that. Okay, so you will see it's a decreasing curve. So one is increasing, other is decreasing, right? So it's called a Phillips curve, and it's one of the famous example of these correlations. And each and every country has this Phillips curve to gauge different kind of factors impacting GDP, unemployment, educations, labor market, and all that. They come up with this sophisticated this visuals called a correlations. They come up with this diagram called correlations, and they try to quantify it, the correlation. Okay, so and the value of these correlations will somehow will range from -1 to 1. Okay, so for example, if there are variables which are strongly correlated but negatively, so that is why their value will be -1. Okay, so and there are a few variables which are highly correlated. Okay, if you increase one variable, other will increase also in the same amount. For example, sales and revenue, so they are highly correlated. So if you are increasing one, other will also increase in same amount. Okay, unless and until you provide some kind of a discount. If you are providing some kind of a discount, maybe your revenue will fall, but it will increase. Okay, so that is called this highly correlated. So that is why it is donated with +1, right? And if there is some correlation called a zero, if value is zero, okay, so it means there is a no correlation. Even if you are increasing one variable, other will not will be affected by any amount. So that is your zero correlation. Okay, so where typically we use this correlation? Fine, let's say if you have 15 such variables, and let's say you are just deciding the price of a 3 bhk, right? If there is some maybe uh, organizations, maybe they are selling the flats and all. Okay, so they just want to predict the price of this 3 bhk and all that. Okay, and they have some 15 variables. Okay, so the price of the 3 bhk maybe, if you have some variable called the size of a room and the square feet of a room, right? If you have two variables, right? But if you see their correlations, it will be much higher, because +1, it will go somewhere in a +1, because these two variables are depicting the same thing. So correlation will help you also out to remove some of the features from your model. For example, if you are creating some kind of a regression techniques. Okay, so in a regression techniques, you come up with a single value predictions, continuous. It predicts a continuous value in regression techniques. For example, if you're deciding the price of a 3 bhk out of 15 features, so price of 3 bhk will be dependent variable, and all other variable would be, let's say if you are assuming 15 such variables, it will be your independent variable. Okay, so in within those independent variable, before you apply any kind of a regression technique, you come up with this correlation. You create a correlation matrix that sometime we call it a heat map, or maybe it's a confusion matrix kind of a thing. So in a heat map, we will see that it's like on a x and y, you try to populate the variables with each other, that what is the correlation of these variables, and they give you a plot that let's say if you have a x1 to x15, you try to create a the heat matrix, and you just correlate those variables with each other. Okay, and those variables give you some metrics and the values. Let's say if there are some variables, let's say x1 and x5 has a value of 0.98. Okay, it means x1 and x5 variables are highly correlated. So before you apply any kind of multiple linear regression, you'll try to remove and you'll try to keep one variables which are relevant to you. Okay, so this is one way also to you can say the feature engineering. One of the, you can say, the techniques that can help you to eliminate some of the features, because you do not require those 15 variables, you just require 14 or 13. So one of the way to reduce these features, because if you have less number of features relevant for this prediction, then that will help you to create much better model, right? So correlation is a starting point also to remove variables. It will help you in a feature engineering, right? Let's say one of the example I'm just giving you, let's say one of the variable you don't know their value. So sometime also regression techniques, backward regression techniques also help you out to fill the missing value. If missing values are in some numbers, what you typically do is you just take help of this forecasting, these regression techniques. Okay, and just to fill it, okay, the value which are missing. So in the both way, your this correlation will help you somehow. Okay, so then comes this regression technique. So regression is as I already told you, is predicting a single continuous value is a regression techniques. So obviously you will have in a simple linear regression, you will have one dependent variable and one independent variable. Okay, so one is a regressor. So And dependent variable, you're trying to predict a dependent variable from the independent variable. So if someone asks you what is simple linear regression, obviously we'll have one dependent and one independent variable, but the prediction, coming from a regression is a single continuous value. Let's say the sales and the revenue. So sales would be, the number of sales would be independent variable, and the revenue which coming out would be your dependent variable. So you are forecasting, or you are predicting this dependent variable, that is a revenue. Okay, so revenue would somewhere fall under this dependent variable. If you see this dependent, so here on a y-axis you will have this dependent variable, and dependent variable in this case is number of this uh, revenue which is coming up. Okay, but when it comes to independent variable, it's number of sales. So number of sales will fall in x-axis, but on a y-axis it will be the revenue. So once you plot, okay, once you plot in a 2D, you will see some kind of a point. Let's say 1 2 3 4 5, let's say there are 10 samples. So you have a 10 samples, let's say 10 months data of sales and revenue, and you're just plotting. You will see some kind of plot like this, and this is a line of best fit. It is called a line of best fit in a regression. So you're trying to fit this line of best fit in this. Maybe this may fall like this may go like this, but once you fit in this, there is something called y equal to mx plus c. It is a simple linear regression, is nothing but it's an equation of a straight line, y equal to mx plus c. Okay, so y is a dependent one, m is the slope, x is an independent variable, and c is an intercept. Intercept is nothing but the value which are cutting on a y-axis is intercept, that is a c value. Let's say if I extend here, you will see it will cut somewhere on a y-axis. So this is nothing but a c value. Or sometime also there is some element of an error. So c is sometime also sometime also termed as an error. Error means how much error this model has, because each and every model is not 100%. The model is not going to give you 100% predictions. They will have some kind of error, or maybe the intercept on a y-axis in a simple linear regression. So there are different techniques to minimize those error, because once you minimize the error, that there will be higher chances of better predictions. So maybe if your accuracy is, let's say, 70.5%, so if you minimize those error through different OLS techniques, so in that case there is something called ordinary least square techniques to minimize those errors. So in coming classes you will see how you're gonna minimize those errors. So if you are minimizing those errors, your model is gonna perform much better, because ultimately, obviously, if you are creating any model, if you are designing any model, obviously your aim would be to just to capture the more variability in the data. At the same time, your predictions should be higher, right? So this is how your regression works, and there are also a multiple linear regression, and in multiple linear regression you will have a multiple variables. So it will capture a multiple dimensions. So here it is a 2D. If you have, let's say, 7 factors, so it will have the 7D kind of the model. So you will have to handle those 7 dimensions data, right? So it's very difficult to understand how your the data points are, where your data points are there. So it becomes very difficult to interpret it. But here we have only 2D, so we are able to understand that, okay, so if data is somehow whether it's a linearly correlated, or if there is some negative correlation, you can easily see. But once your dimensions increases, once your features increases, obviously dimensions will increase. At that time it's very difficult to interpret it. So there is also a concept called interpretable ML techniques, or maybe there is something called explainable AIML. So whether your model is explaining or not, whether your model is, let's say, explaining things or not, uh, that can help you also. For example, Simple linear regression is, it's a self-interpretable. You can easily see your model, how your model is behaving, and how your input is coming up with the output. You can easily say it's opaque, right, in a simple linear regression. Also in a multiple linear regression, I'll show you how you can see that how predictions coming up, because it's a weight associated with each and every features. So if you have some features, let's say x1 to x5, each features will have some kind of a weight attached to it. Okay, and you can easily figure out based on those weights that okay, my model is giving this much predictions. So exactly the reason of these predictions. But there are also models where you do not know if they are using some kind of a deep learning technique. So at that time, it's very difficult to interpret the model, because you will have predictions, but you will not understand that how they have come up with this kind of a predictions. Okay, because there is also no weight attached to it. They have a sophisticated algorithm. They use it in their black box, right, in the black box layer. Okay, at that time you will feel the use of then you will feel the need of this interpretable and explainable model, right? So coming to this the qualitative approach, because it's very interesting, that is why I'm just showing you this slide a little early. Okay, so when it comes to this qualitative method, so it's a more of a judgmental, right? You try to judge it through your opinion or through your experience, because obviously we live in a democracy. Okay, so the people's opinion matters. Sometimes we become judgmental, but when you try to capture the sentiment of entire population, somewhere we see that where people fall, because if someone has some opinion, obviously people will have some opposing opinion to it. Okay, so those two opinions, this kind of opinion help you also to formulate, right? So if you see, if you're trying to generate, create a new product. Okay, so the first of all, what we typically do is we try to create some kind of idea generation. Okay, idea generation is kind of you can say you try to ideate it. You sit with different people, maybe CTO, CFXO, different consultant come together, and you try to create some idea that what we want to achieve. You try to create some prototype. There is some kind of a brainstorming happens when you design any new product. Okay, maybe it's a digital product or maybe it's a physical product. Okay, then maybe in your group there are, maybe let's say 10 people were there, maybe there is a high chances of 5 people come up with the innovative idea. Then you try to screen the idea out of those 10 people or 5 people. Okay, then there is something called a concept development and testing. It's nothing but it's more of a POC. Okay, trying to create a POC, it's a more of a proof of concept, because in any organizations, if you go, obviously they do not give you a tender or they do not give you a project, right? So what they typically do is, once you ideate, once you ideate it, once you have an idea, then how mature your idea is, that can be proved by this POC, proof of concept. So they will tell you to create one small project or maybe a small the working model, so that they can see whether this idea is whole proof or not, whether this idea can work once you design a whole sophisticated system, a huge systems. Okay, for example, maybe let's say one of the organization, let's say maybe healthcare. Let's say take an example of a healthcare industry. Let's say one of the private healthcare industry, they just want to design one of the the AI systems where they just want to capture the each and every maybe the patient's data, and based on those data, maybe their historical, the you can say the blood test, the drug that was recommended to that patient. So they have this data. okay, and they just want to forecast it or predict it, that whether the which all blood tests they require, or what is the maybe they are highly vulnerable to, they may have some kind of a disease in near future because they have this kind of a blood pressure, maybe other factors. Okay, so they just want to create one systems by capturing the historical patient's data, right? So obviously, if you have an idea, you ideate it, you screen the idea and all, but the POC at POC level, whether that concept is feasible or not. It's more of a feasibility test. You try to understand whether these concepts are feasible or not. Okay, so this will help you also the in a new product development, the concept development and testing. Okay, at the same time, you try to test it with the unseen data, whether it is working or not. There is something called user acceptance testing, that is UAT. So whenever you design any product, you try to test it in a UAT environment, and then you go with this a prod environment, that is called a production environment. Okay, so once your client approved with the UAT data, and once your product is passed at that level, UAT, user acceptance testing level, obviously you are good to go with this the prod environment. Okay, then it's a go to live, right? And then there is something called a marketing strategy. You decide once you're obviously once your product is qualified, and then on top of it you try to create some kind of a strategy. Once your product is with you, obviously you'll try to gather some kind of a the volume, some kind of revenue out of it. So marketing is more of kind of attracting of people to buy those product and services. So you will see in a market, you'll see different billboards, maybe in the TV advertisement comes. So or maybe you will see different kind of a digital strategy, digital marketing strategy, maybe online and offline. And there are also celebrity, this marketing strategy. You come up with the different celebrity and take help of those people, so that people will have some kind of a confidence attached to it, that okay, this if this product is being sold by, or maybe this product is being marketed by XYZ personality, there is higher chances of product to be genuine one. Okay, and then on top of it, once you have a data, right, and the fifth this stage, you have something called a business analysis. So once you have a data, because up to fourth level you are able to capture some kind of data, right? So on top of it, you are trying to capture this business analysis. You try to analyze those you can say a business, right? Maybe there are different KPIs to be captured. For example, number of sales happening in, let's say, an XYZ area, how much sales happened previously, okay, and who are the target customers, and who are buying more, and who are the area which are vulnerable, who are not buying, whether male is buying more or female is buying, or the products which are you are selling is female centric. Okay, if it's a healthcare, okay, so you'll see that which area, which demographic area has this kind of a disease, and who are likely to get this kind of a disease, right? So maybe you try to capture this kind of a KPIs, maybe more in a dashboard manner, because dashboard is something, it's a collection of different stories or business cases, that which KPI is working better and which KPI is to be taken care of. So business analysis is more towards the historical data, more of a diagnostic analysis on top of it. Okay, and once your product development, and then there is a test, market, and commercialization. So these are the some steps you try to follow it. Okay, so test marketing is like you just try to create a small use case and try to sell it out, and once your product is complete, you try to commercialize it. Okay, so the product development, the life cycle goes like this. But how this quantitative method, there are different methods which I have discussed. But when it comes to this opinion, the survey, opinion survey is the consist of this different views you try to gather it. Okay, so opinion is for example, whether you just want to understand the opinion of a people. Let's say the different policy, different government just rolled out, for example, in different states, government come up with different Jan Kalyan Yojana, right? Maybe some of the the you can say schemes which are related to the woman, right? They give some amount, let's say 2,000 per month to each and every single female. Maybe they are given a different, maybe if your age is more than 60, maybe you get some kind of maybe 3,000 4,000 rupees per month. Okay, so what is the opinion of a people about these kind of services, or this kind of uh, what people think about whether it's as a good service, or maybe um, maybe these schemes are good or not. So people do capture it through this opinion survey. What is the people's opinion? But when it comes to this opinion survey, you will see day to day life, you will see this kind of an pollster use this opinion survey, right? So they try to capture the opinion of a people, and then they try to forecast something out of it. Okay, these are some qualitative. There is no quantifiable measures. They say that, let's say out of 5,000 people they had a word with, and how the opinion they captured out of those 5,000 people was, let's say this party is winning, right? So these are the some opinion, but it's not quantifiable. But they try to capture their the uh, you can say a kind of abstract, and they try to capture it, and then on top of it they create some kind of this opinion poll. Opinion poll might be sometime you can say accurate, but it's not 100% they are accurate. But but why people do this kind of opinion survey? Because opinion survey gives you, ultimately you try to capture the data. It's a this primary data, you try to capture it, because the primary data is something which are very critical one, because it tells you a whole the story. For example, you might have heard of a concept called this sentiment analysis. Okay, so in a sentiment analysis, for example, Apple has this 15 Pro or 16 Pro, right? And they are selling this right in the market, and they just want to understand the customer sentiments for this product, whether this product is good or not, or what people are thinking about. Okay, so one of the way is to go with this opinion survey kind of a thing, and they capture the the sentiment towards these people. This will also fall under this kind of opinion, because it's more of an opinion only, right? Maybe it's a positive opinion, negative, or maybe the neutral opinion. Okay, similarly you will see different this e-commerce platform. If you open your Amazon store, right? So on Amazon store, if you buy any product, you will see on below of it, you will see the people are giving the feedback. Maybe there some comments are there in each and every single product. Okay, maybe if you are buying some electronics product, you will see below, you will see different the comments, and different feedback are there, that okay, I bought this product, but after 5 days there is a problem with the battery of this cell phone, maybe earphone is not working, or maybe there is some RAM issue, right? So these are some the opinion, these are some feedback. But whether it's translating into people's opinion or not, because once the feedback is compiled, it will be the opinion of the people, right? So you are capturing it away in a way that it helps you to design the product and services. You easily address it, because people are not if you are not attaching, or if you are not creating a feedback systems, you are not able to the capture the the you can say the improvement or the suggestions of the people, right? Then only you can try to improve the product and services. Okay, so then comes this market research. Market research is more of a, you can say, you might have heard of this marketing research at the same time. That there is also a topic in your MBA. You might have this market research or marketing research. Okay, so the gather information about the target market and customers. So in market research, you try to gather the informations about the target market. For example, your target market is only your tier 2 or tier 3 cities. You try to capture the the information about this market. Okay, and one of the important of this market research is just to create some kind of a strategy. Okay, so that you will be always in the competition. Okay, so market research is very much important, because each and every organization, if you go with this big four organizations, they do a lot of this market research. They try to go with this market trends, so that they can beat the competition. Okay, you might have heard of the big three company, BCG, maybe the Bell and all that. So what they typically do, they take help of this. There is something called a BCG matrix. Okay, and they design it. This kind of strategy to this kind of a strategy. This market research also help you to identify and analyze the need of a market, and obviously addressing this competition. Okay, so as I given multiple examples that in a market research, uh, how to beat the competitions. So we have a different the matrices. There is something called BCG matrix, and there is also called a SWOT analysis: strength, weakness, opportunity, and threat. So once you're designing any product and services, or maybe any kind of the product, maybe the digital or a physical product, so you try to analyze the this kind of a market, the strength, weakness, opportunity, and threat, uh, through this market research and all that, whether if my the if I'm selling this product at, let's say, 10,000 K, whether I'm able to capture the whole market or not, and what is the the who all are the competitors in the market. Maybe you might have seen when the cell phone was launched. At that time, we had a whole lot of this cell phone, right? So cell phone, there were different organizations, they were selling this this cell phone. So at that time there was huge competition. So someone used to give this RAM 4 GB, 6 GB, maybe their external memory was 128 GB, 256 GB or something, right? So how they were coming up with this kind of offer, they had some kind of a market research. Okay, so also in the market research, it also includes some kind of a social and opinion research. Okay, so this helps you also to beat the competitions, and also create a better business strategy. So market research is somehow backed by the the quantifiable numbers. So that is a majority of the company take help of this market research. Okay, so then there comes a Delphi method. So Delphi methods, you might have. I'm assuming that you are familiar with this Delphi methods. So Delphi method is, I mean, it's like written questionnaires, the form of a written questionnaires. This allow independent consultation and debate, thus avoid pitfall of direct confrontation, both social and when it comes to geographically dispersed participants. Okay, so Delphi methods what typically do. So you give some kind of a form or a questionnaires. Okay, and this allow anonymous and independent the consultation and debate, so that you try to capture it. Okay, for example, you invite different people, and you give this kind of a questionnaire. Okay, so after first round, participant evaluate if they agree the formulation and want to clarify their views. Okay, so in a questionnaire, for example, you have given, let's say, questionnaire to these many people. Okay, you invited people to answer these questions, then you try to analyze it. Okay, and then if you have any the further questions, or maybe if you found out that the question to be improved, then you try to improve these questions. Okay, so this allow iterative way of the iterative, you can say, approach to gather the opinion of different experts. Okay, so it's a more of a the qualitative way of forecasting, because you try to gather the intellect of different individuals, and on top of it you try to forecast it. Okay, for example, let's say a Maruti Suzuki, there is an organization called Maruti, let's say, and if they are creating a new product, they want to launch a new product in the market, okay. So obviously they will have they set up a bench and they try to forecast it that how much what are the different way to accelerate the the selling of this product and services, and what could be the the better way to improve the the designing of the Maruti, let's say Maruti X, okay. So this method can also help to gauge before rolling out any product and services, okay. So then there is something called a test marketing, okay. So you might have familiar of this test marketing. So and you might have come across this kind of test marketing, because you will see in the market that people come up with this maybe you might have seen the juice company, they give you a can of a juice and then they tell you to just try it. So okay, so they are not charging anything, but they try to capture whether it's their taste is good and what was the good and bad. This is a more of the test marketing is to before launching any product, you just select a small market and you try to see that what is the the reactions of the people, and then you capture it, okay. For example, if you see a limited launch of the product to test this marketing program and the reaction of a potential customer in a real world setting, okay. So before, let's say if you're launching any, let's say any maybe what I am suggesting you, for example, any drink product, okay, or maybe any healthcare product, okay. So before you are launching, or maybe any protein shake, let's say if they are any company is launching protein shake and they just want to capture the opinion or maybe the reaction of the people. So before they launch it, they create some test market in a real setting. They go in a market and randomly they select a people and they offer this drink, right? And they try to see that what people are talking about, what is their reaction to it, whether they like the taste of it or not, whether they had some kind of a problem while consuming it. So it will help also to on top of it to also, if they find out that there is a there is a need of some correction to be added, or maybe the flavor is not good, they'll try to change the flavor, okay. So this will come under this test marketing, okay. So there is something called a standard test market. So there are three approach. Second one is controlled test market, and third one is a simulated test market, okay. So in what typically happens in this standard test market, okay. So in a standard test market, you see a few cities are selected, okay, and they try to do the full marketing campaign in that, okay. And they try to capture those some kind of KPIs. So cities chosen are said to represent the population at large. For example, Ohio in USA, London, Ontario in Canada. They have selected this one, okay, the place before the launching of the product. So it will fall under standard test marketing, okay. Then comes this controlled test market. For example, a panel of predetermined stores carry the new product for free, okay. You might have seen in one of the the big this there are different organizations, for example the Big Bazaar or maybe the Reliance Trend. So in the controlled market setting, what they typically do is they pick up a store and then they give you a product in a free, okay. So at a limited time, so that they just want to understand that what are the the reaction of the people, and in the controlled market setting whether what people are thinking about, because ultimately if you are able to target a large volume of a population at a limited time and you are able to capture their reactions, it will help you also to revive, or you can say if there is some problem with your product before launching it at a bigger event, you can avoid this kind of a pitfall, okay. So that is why control market setting also help. And there is something called a simulated test market. So sometimes fake stores are created to simulate a real shopping experience. You might now AI has you might have seen the AI, and there are different way to market it now through the artificial intelligence, through different Gen AI concept. So you might have seen people, if you stand in front of a mirror, they if you put any clothes, how you look once you put the real settings. So it will show you, okay, if you wear this clothes and this color, you will look like this. Okay, so this is nothing but a fake store, but they are giving you a real experience. Okay, it's more of a simulated environment. They give you entire simulations, and creating simulations, creating a fake environment, but capturing the real, the behavior, you can say the real reactions of a customers. So this will come under this simulated test market. Okay, so now if I see this qualitative, then comes this quantitative methods. If you see with this quantity methods, there are different methods, and it's very easy. You might have come across. So naive approach, as I already discussed. So now I'm coming up with this quantitative methods. Okay. So quantitative method, first of all, this naive approach. Naive approach, obviously, it's just a starting point. Just your gut feeling that something you just sold in January, the unit was 68 unit. You were able to sell it. So maybe in February the same amount you're gonna sell, or maybe a few quantity less or more. So it's a naive approach, but obviously it's a cost effective, because someone, maybe the one of the owner of the firm, is deciding, okay, this will be the forecasting. There is a no mathematical models attached to it. There is a no fundamental concepts. This is just a naive approach, right? But when it comes to moving average, okay, that okay, let's say you have a data, historical data of up to 12 months. Maybe the next year in January, what will be the sales? So you'll have a historical data now. So moving average is a series of arithmetic means, used if little or not, used often for smoothing. Okay, so I'll tell you what these things is, a moving average and all that. For example, up to 12 months, let's say the previous year in 2024, some store had the sales and revenue data with them. Now they want to forecast it in the next 6 months in 2025. What will be the number of sales and what will be their revenue? Okay, so both can be easily forecasted because they have a historical data of a 12 months in each and every month. So here, if you see the example, moving average equal to demand in previous n periods divided by n. So n is here 12 months. And what was the demand? You'll have to add all the demands. Let's say demand in January was, let's say, 100 units. In February it was 105. In March it was 99. In April, let's say it was 105. So you're gonna add it, and then you divide by 12. So it gives you an average, that this will be the average. Let's say the average comes out to be 101. Okay, so 101, maybe in the next year 2025, the average one company can accept, they're gonna accept this is 101 unit. They are able to sell it. They are very much confident because the historical data is telling that even if you have some kind of a problem, you will able to sell up to 101 unit. Okay, so this is one way of moving average, because if your store is if you are not able to create a sophisticated algorithm, but if you have the historical data, you can easily come up with this moving average, because it's a some kind of logic, some kind of a mathematical models attached to it. Okay, so now I have given you the example, right? So in this example, let's say in January they were able to sell 10 units, and in February it's a 12 units, in March it's 13 units. Same goes with October, November, and December. You will see they have these units they are selling. But what will be the sales in January? Let's say it's a data of this entire year 2023 2024. So what will be the projected sales figure in 2025 and 2026, right? So how they gonna decide it? This is their historical data now. Maybe they have maybe 5 years old data. Maybe they have 10 years old data, but there are also a factor before I explain you this moving average, because it's easy to calculate the moving average, but there are also different factors which are attached to it. It's not like in isolation you can say that okay, maybe if 15 units are coming in each and every month in 2025, people will have 15 units based on this forecasting. But you have to also take care of the market, the how market volatility of the market. Let's say you are selling any digital product, there are highly chances of maybe the market will change, the customer's behavior will change, so that will impact your forecasting. It's not like it's static forecasting. There are also some dynamism. There is some kind of irregularity in the market. Maybe there's some pandemic, this pandemic attack. So if your forecasting is not taking care of this kind of unusual patterns in the market, obviously your forecast would be obviously it will be a fake forecast then. But we are assuming the market to be idle, then you are forecasting it. Okay, so in a moving average, let's say we are assuming the 3 months of moving average and months moving average. Now we are adding 10, 12 and 13 and dividing it by 3. So what is the unit cells? Okay, it will be 11.2 by 3. Let's say 11 and 2 by 3, it will come under some fractions. But the unit of sold can't be in a fraction, so try to keep it in a whole number only, like 11, 12, 13. Okay, and again you will see we will keep 12, 13 and 16. We will keep 1. Okay, 10, 12 and 13 here. We will stop, and then we will leave first one, and then 12, 13 and 16. Same way we will go down. Okay, so these are the forecasting, 3 months forecasting. It's a weighted one somehow. Okay, 11, 13, 16, 19, 22, 26. Okay, and 28, 25 and 20. Okay, so these are the some, you can say, the moving average. So this is forecasting techniques. Okay, so in April 2025, maybe your model has predicted that 12 unit, approx 12 unit, you're gonna sell it, and the highest you might sell in October. Okay, based on this. Okay, so weighted moving average, as I already told you, they'll have some kind of a weight. Okay, weight for period n and demand in a period n. Okay, and divided by weight. So in a moving average, we have only the average we are just calculating, but there is no weights attached to it. Okay, but in weighted moving average, you try to capture the weight also. Okay, so here if you see, the data is the same. In weighted moving average, you are taking the same data here, 10, 12 and 13, and now just see how we are calculating this weighted moving average. Okay, so 3 into 13, 2 into 12 and 10 into 1. This is first month, second and third month. Okay, and 3, 2 plus 1 divided by 6. Okay, we are also giving the weight, multiplying with the weight. It's a third month, second month and the first month, and all the month together, 3, 2 and 1, that is a 6 divided by 6. It is 12.1. It's a weighted average. Okay, so in a, let's say it's data of 2024, what will be the the number of units sold in 2025 in April 2025? So it will be 12 unit. You are just removing the fraction. Okay, it's a 12 unit approx. In May 2025, it will be 14, 17, 20, 23 and 28 or something like that. So this is a weighted moving average. Okay, you are also capturing the weight, so that our model will have some kind of higher accuracy. That is why you are also attaching a weight, because it will reduce the error. Okay, so the moving average, and then comes this weighted moving average. So the formula is same, you can easily create it. Okay, now in a weighted moving average, if you see, so 3, 2 and 1, how we have calculated. Okay, it's easy. So number of sales happened in the last month, then number of sales happened in, let's say, second month, and the number of sales happened in first month, and the sum of the weights, like the weight was 3 in the last month, 2 in the second month and 1 in the first month. So 2 plus 1 3 and then 3. This is the 6. Okay, the simple one, you can easily create it. Okay, so now how this exponential smoothing works. Okay, so now exponential smoothing, if you see, form of a weighted moving average, it's a part of a weighted moving average. Weights decline exponentially. Most recent data are weighted most, and it requires something called a smoothing constant alpha, and the alpha value ranges from 0 to 1. If you see this one, okay. Now, how this exponential smoothing works, okay. So here it is just extension of this weighted moving average. So it's a bit of a math attached to it, but I'll show you how you can use this exponential smoothing. Okay. Here it is saying weights decline exponentially, because whenever you put e to the power, let's say x, so it will have a negative correlated graph. You will see it's like a decaying constant. It will decay. Okay, when you put a exponential of something. Okay, so now this is just a formula. Don't go with this formula because you don't need to just remember all these things, but you need to know that few terms here. For example, in a smoothing, exponential smoothing, you just want to create a forecasting, a new forecast. Last period forecast plus alpha. Alpha is nothing but alpha is a smoothing constant. The last period actual demand minus last period forecast. Okay. So how you gonna calculate this smoothing? Okay. So it's an extension of weighted moving average, the exponential smoothing. Okay. So how you gonna calculate it? Okay, that is more important. So we have come across this moving average, weighted moving average, then exponential smoothing. Okay. Now, for example, one of the example is predicted demand was 142 Mustang. Okay, Ford. Actual demand was, let's say, 153. So, and a smoothing constant we have to select between 0 to 1. Okay, here people are assuming the ideal case is alpha equal to 0.2. So what will be the new forecast if you have been giving the predicted demand is 142? Let's say in 2025 Jan, the actual demand for this Ford car was 153, but your model predicted was 142. Okay, but if you apply this smoothing, okay, if you apply this smoothing, how you come up with this? Okay, so new forecast in a January 2025 would be your demanded predicted was 142. You are adding this smoothing constant, and what was the actual demand and your predicted demand. So actual and predicted is some kind of an error, right? Your actual demand was 153, but you predicted 142. Okay, less than 11 unit. Okay, less sort of a 11 unit. So it's a more of a error, you can say. So you are minimizing the error, 0.2. You are minimizing the error, right? So new forecast would be the demand which you have forecasted and the error element. Okay, so that is why it's you are try to smooth it, right? The error while forecasting a new forecast. Okay, so it will give you a forecasting. A new forecast means in, let's say, in February 2025 it would be 144 cars. Okay, but if you see the predicted was 142. Okay, so exponential smoothing, if you see this one, the constant, the element of adding this alpha multiplying is just reduce the error. Is nothing but how much you can reduce the error. Okay, this is nothing but reducing the error. Okay, if you don't multiply by this, you will see 153 minus 142, it's 11. So you will add 11. Just see how much forecast it's gonna top the the forecast. So you are adding more error, but now you are just minimizing the error. Okay, you see your predicted was 142 and closer to 144. You have minimized the error right now here. How? By adding this exponential smoothing, by adding this factor 0.2. Had it not been there, you will have added more error to it. Your forecast would have gone in different directions. Okay, that is why it's very much important to take help of this exponential smoothing, right? So if you see this one, the naive approach, the first one was naive approach, second one is moving average, then weighted moving average, then exponential smoothing. So this is how your the forecasting works, from naive approach to exponential smoothing, because you are trying to improve your forecasting, right, in that directions, and you know that where you want to apply this kind of forecasting techniques. So coming up with this forecasting techniques, okay, so we are able to do this kind of forecasting techniques. So now this topic is over. So let me just pull out another PPT and just show you. Just give me 30 seconds.
Okay, sir, no problem.
Okay, okay.
Sir, are you 2 hour class?
क्या बोला?
Sir, are you taking 2 hour class now?
Yeah, we have now 20 minutes left. Okay, so
Okay.
so if you see this one, I hope my screen is visible. So if you see this one, you have this forecasting techniques. So we are able to cover this forecasting philosophy, the different processes of this forecasting and different methods of forecasting. Okay, and then comes a technique called correlation. Okay, so let me touch upon this correlation. Okay, just a small unit, because it's related to this forecasting somehow. So just let me throw some light on it. Okay. Okay, so before I go, just use this. So today I just discussed this regression technique. So just see this one, just a small, a huge case here, so that your concept would be a bit clear. So just see. Where is that? Okay. If you see this one, dependent and independent variable, just see this one. It will help you also. So in independent variable, if you see the amount of water, okay, and the dependent is plant growth. Okay, so I'm just connecting you that if you are giving water to the plant, okay, so there will be growth in the plant, so it will be dependent variable, because majority of the time people get confused with dependent and independent variable. Okay, so plant growth, you can quantify it, that in a 1 month, you if you are given, let's say, 1 gallon of a water, so plant growth was 5 centimeter, let's say. So the both parameters, both features are quantifiable. It's a continuous number. So that is why it's very much important to understand that, because in your this interview, typically people do ask that what is difference between correlation and what is difference between regression and classification. People do get confused that what is regression and classification. They do merge the answers. Okay, so classification is like, you are just classifying it whether it's a two category or maybe multiple categories. Okay, maybe let's say some candidate is gonna win or lose, or maybe you can say someone has the COVID or not. Maybe bank will give loan or not. So the binary, majority of the time you will see the binary classification. Let's say some household will get some gas connection or not. They should be given a gas connection or not, depending on the different features. Okay, but the classifications typically, it's like a discrete values. Okay, but when it comes to regression, it's a continuous value. Okay, so dependent and this independent, I'm just connecting topic to this correlation and causation. That is why I'm giving you the clue of this regression techniques, that how you can connect with, because the correlation and causation is such a topic where people do get confused that if something is correlated, is it also a region of causation. Let's say if you have a higher if someone has, let's say, high temperature, maybe they will have a likelihood of COVID. So maybe the causation is due to the higher temperature. It's a causing, right? But there may be a chances, for example, it's a heat. Okay, and it's not a, let's say it's a rainy season. Okay, and you are eating some food, hot food, let's say, outside. Due to that, your car stops. So it is due to eating of those the hot cup of tea, or let's say due to that your car is stopping. Is it causing? So that is the one case that you have to find it out, whether causation is correlation or correlation is causation. Okay, that is very much important to understand in data science. Okay, so if, let's say, in this regression techniques, you try to capture this cause and effect, right? If something is happening, whether it's a cause or not. But there are also a different approach. There is something called ANOVA, Mancoba. In coming classes, I'm gonna teach you this ANOVA and all that. So that also captures this causal effect. Okay. Regression, as I already told you, because it's a simple linear regression. Okay. But my point is that I just want to show you this in a regression techniques, that as I already explained you this is an intercept y equal to mx, m and x1, m is here b1, plus this one is error term, which I have already explained. And also in a exponential smoothing, you might have seen this error part, because error is something that ultimately you have to reduce it. Okay, so this is nothing but error part. You have to take care of this error part. Okay, so my point is, this is your line of best fit, and this is a slope. Okay, and this is a intercept. So y equal to your dependent variable, x1 is independent variable, e is error, here this is intercept, and b naught is your slope. Okay, sorry, b1 is your slope, b naught is your intercept, and e is error term. Okay, so intercept is nothing but anything cutting on y-axis is your intercept. So when you want to learn this simple linear regression or regression, it's nothing but the equation of a straight line. Just remember that. Okay, so this is how it works. Maybe there might be a case which I just want to show you is a line which is passing through it. Okay, pass through as many points as possible. So in a linear regression, your model is trying to come up with the best fit line. Okay, possibly this is a best fit line, possibly this is your best fit line, possibly this is your best fit line, depending on the model which they learn from your historical data, right? So they capture the line of best fit. This is how they capture it. Okay, so in regression, if your regression is strong, your this forecasting techniques, you will easily understand this forecasting techniques also, because there are many terms which are so synonyms to this regression also. Okay, the slope, the intercept, the error, the root mean square, line of best fit. These are the some terms which will come across. That is why regression is very much important, because also in econometrics, your base is regression only. Okay. So, as I already told you, I'm just going through this slide. I will be also explaining you in coming, sessions also. But let me give you an idea that how the value comes up and the few terms you get familiar with. Okay, the number of you can say the method of least square. Okay, so how you are going to minimize the error? This is error part. This is a predicted and actual one. When you run this linear regression model in a Python or in a R, right, their aim is to reduce the error. Ultimately, they continuously do the error part, they try to reduce it. There is something called a root mean square error, RMSE. Okay, the formula is this one only. They try to constantly remove this error, then they come up with this line of best fit. Okay, might possibly line of best fit is very closer to this point, but it's very much away from this line of best fit. This point is very much away. How you can reduce this error? Okay, this one is also too away from your line of best fit. So error is nothing but what is the actual and you are predicted. They try to just minimize it. Okay, this is a least square method. In a regression techniques, you have this a root mean square, least square method to minimize the error. Okay, now I'm just giving a small example here so that it will stay in your mind. For example, a person's salary, let's say experience is 2 years and he's getting $15,000, let's say. And if someone has experience of 16 years, he's getting $90,000 per month, let's say, or per year. Okay, let's say it's a per year. Okay, now you have been given a task to predict. Let's say if someone has, let's say, 7 years of experience, what they're gonna get typically in US market per yearly. So here there is a one dependent variable. Salary is a dependent on number of experience. So year of experience would be your independent variable, which is independent. But once you are attaching this year of experience, you get some kind of a salary, right? Your salary is $64,000 per year if your experience is 13. So this is historical data. Let's say it's one of the, let's say it's a Walmart, and we have let's say 15 such candidates, and their salary is this one, their employee's salary. And if a new employee comes in and you just want to predict it, so what would be their salary? Okay, so this is one simple way to come up with this linear regression, because we have one independent and one dependent variable. So you can easily fit in this line and you can easily interpret it. Okay, if someone has a 7 year of experience, what is their salary? So if you see this one as salary is a continuous value, single value. My attention here is to show you this is a regression case. Why? Because this is a single value, 90, 58, 8 and 54. This is a single continuous value it is predicting. Okay, so dependent and independent variable. So dependent is salary and year of experience is independent value. Okay, so based on this you try to formulate some kind of a regression, y equal to mx plus c. So this one, once you are able to find out this equation, you can easily predict it. You know the y is your salary and x is your year of experience. If you are able to find the weight, that is m, the slope. Okay, y equal to mx plus c. You know the x, you know the y. Oh, you don't know y, but you know the x, but you don't know the weight of it. So once you fit in this regression line, you will come up with this weight of x1. and if you put the weight of x1 into your model, you are able to predict it y. Okay, so mathematically this is how it is calculated. Mathematically, I'm just running it through. Mathematically, if area of accidents is 2 and salary is 15, so root mean square y bar minus y, right? So we are just creating the average salary is, let's say, 45.44. You are trying to reduce it and make it a square. Hello? Hello? Okay. So this is how you are trying to minimize the error. Okay. So y, ultimately we just want to create y equal to mx plus c. Okay, mx and c. Here y equal to mx plus b, just don't get confused with b. It's the same thing. It's an intercept on a y-axis. Ultimately, we want to achieve this, the slope of m. We know the x, we want to predict y, and we just want to know the intercept. Okay, if we know m and b, we can easily predict y. Okay, so this is a mathematical way to create simple linear regression. Mathematical way you can easily create. Okay, in a Python, just we have a 2 line of a command you can easily create. But on top of it, how your model works, this is how your model works. You first you create an average. You just calculate the average and just you do minus of it in every single the row. And because some numbers are in negative, you just want to make it a positive, so it's a better way to square the error. So that is why it's called root mean squared error, because the error which are in negative can be converted into the positive. That is called sum up a squared error. You are just trying to sum it up, and the squared error is this one. Okay, and this is the formula. It's a ordinary least square method. Okay, just see it because I'll show you through the Python. My point is just to see, so that once I again teach you this one, you will have something in your mind that how regression works and how the error part was eliminated, how it was reduced, what is y, what is m and s and c, right? The formula is this one. You just put in this formula in this one. Okay, you had x1 y1, you just had a this average x1. These are the formula. Okay, you have to put in this entire formula. Okay, you have calculated it through this one. Okay, and by inputting all these things, you are able to create this equation y equal to mx plus c. Okay, so m is this one, 1037.8. This is summation. Okay, and summation of 1.6.9, this one you have calculated. So m, you are calculating it this one by this one. So this above this one is this your column, and below x1 minus x1 bar, okay, predicted and actual one, is this one summation. If you divide it, you'll get a m is nothing but a slope y equal to mx plus c, and this one is a b is nothing but your salary, the average salary, okay, minus 4.80 cross 7.5, this one. Okay, so this will give you the slope, multiplying the slope y equal to, okay, m and x bar. So you are just, for calculating this b, we have to multiply it with slope, and whatever was there in x bar, you just multiply it, you will get a b. Okay, so b equal to y bar is 45.44 minus m multiplied by x bar is 7.5. So hence you will get y equal to 4.80 x plus 9.15. This is your equation finally. If someone has, let's say, 7 year of x is 7, just multiply by 7, you will get predicted salary y. Okay, this is how your regression works. And on top of it, when you forecast it, okay, so this kind of equation you come across. Okay, so but in this time series analysis, you'll have an element of a time. Okay, that makes a different from this regression. But regression and time series are different, but inside it there are different concepts which are attached. For example, correlation, causation kind of a thing. These things will be attached. Root mean square kind of a thing. So on the basic will have this kind of a concept. So don't get confused this regression and time series analysis. Okay. So my point was just to make clear the regression one, because once your regression is quite clear, you will apply some of the concept in this time series analysis. Okay. So this is how it works. Okay. So finally, in Python programming, I'll show you how regression works when this topic comes, but just remember the few concepts of it. Okay. This is how it works. So, okay. So I'm done for today. Take attendance. Where is take attendance? Where is Sakshi? Sakshi is there or not? Sakshi, are you there? Deepak, are you there? Deepak? Hello?
Hello.
Yeah, Deepak.
जी सर बोलिए।
Yeah, are you there? Yeah, Sakshi is there or not?
सर साक्षी का नेटवर्क ग्लिच की वजह से सर वो लेफ्ट कर रही है अभी थोड़ी देर पहले जस्ट।
Okay, take attendance and give it to Sakshi, okay?
ओके सर।
Just take attendance and give it to
सर
her.
गिव मी 5 minutes प्लीज।